So this chapter section is going to be about the fundamental counting principle. So pretty much you've done this before in like 6th or 7th grade. Now we're just going to do the more mathematical way. So now we're going to have 2 events instead of 1 event. So the past 2 sections we've only had like 1 event occurring at a time. Now we're going to have 2. So for example, suppose you have blue jeans or black pants. So with a red, green, or blue shirt, how many different combinations of outfits can you have? So if you look over here to the right, the long version, in 6th grade you probably made a little chart that looked like this, and you would break apart all your different options and figure out how many there are. So if we look, there's 1, 2, 3, 4, 5, there's 6 different options. So now we're going to just do it the mathematical way. So you have to break up your different options. So if we look here, we're going to put M. We're just going to match up what we have. So we've got pants and we have shirts. So pants and shirts, it doesn't matter which one you make which because you're going to be multiplying. So if we look at our pants, we've got jeans or black pants. So there's 2 different options. And if you look at our shirts, we've got red, green, or blue. So that is 3 different options. And then to get your total options, you just multiply them. So you 2 times 3 would give you 6 different options, which that is a lot quicker than making this tree diagram over here to the right. Now, the next example is that the deli offers a lunch special. You choose a sandwich, a side, and a drink. So how many different combinations can you have if they give you the menu over to the left? So we've got a sandwich, you've got a side, and you've got a drink. So if we look at the menu, there's 1, 2, 3, 4, 5, 6 different sandwiches options. There are 4 different side items. And there are 5 different drinks options. And again, with the fundamental counting principle, we can just multiply everything together. So 6 times 4 times 5 gives you 120 different options for lunch. So our next problem, we have a password problem. So your password can be a letter followed by 2 digits. So for example, you can have R38. And it says that the numbers can be used more than once. So you could have R88. So you could use the numbers twice. So that means that we have 3 different categories. We've got a letter, and then you have a number. And your numbers can only be 0 through 9 because those are the only single-digit numbers. And then you have another number that's 0 to 9. So for letters, there are 26 letters in the alphabet. So I'm going to put 26. If we count 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 different numbers for the first number in our password. And then we have another 10 numbers to choose from for our second number in our password. And then again, you multiply them all together. So you get 20.
Mrs. Velez, please report to the guidance office. Mrs. Velez, please report to the guidance office.
And so again, if you had 2,600 options, if you were doing a tree diagram, this would take you a very long time. So next we have a factorial, and that is multiplying a series of descending natural numbers. So just you descend the numbers from whatever factorial it says it is. So for factorial, the factorial symbol is the exclamation point. So you do 4 times 3 times 2 times 1, which gives you 24. And then for 7 would look like 7 times 6 times 5 times 4 times 3 times 2 times 1. And that gives you 540. Now you have to stop at 1 because if you go to 0, then the 0 times anything would just give you 0. So the factorial is from the number it gives you all the way down until 1. And you multiply. So 1 has nothing past 1, so it's just 1. And what you use factorials for is saying you're like trying to order things or line things up. So example, we have 4 people and you want to put them in a line. So this would be 4 factorial, which we just saw gave us 24. Now, the way that we know this, if we actually worked it out, we have 4 people in line. So you have the first person. So we've got Bob, Cindy, Larry, and Mo. So for the first person in line, I could pick any of them. Nobody's in a spot yet. So I'm going to pick Bob. So I have 4 different people I could choose from. So I have 4 choices for my first person line. Say we pick Bob. So Bob is in line. Then our second person. Now, since Bob's already in line, I can't put him first and second. He can only be first. So I don't have Bob to choose from anymore. I only have Cindy, Larry, and Mo. So I have 3 people to choose from. Now we'll say that we put Cindy second in line. And then I go to the third person in line. Well, now for the third person in line, I cannot put Bob or Cindy in that spot because they're already in the first and second spots in line, so they can't be in two spots at once. So I only have two choices. I've got Larry and Mo, so I'll put Larry, and then for the last spot, only Mo is left without a spot to go. So there's only one person that could go there. And again, we could have ordered this differently. We could have put Cindy first, but no matter what, whoever we put first, each time we're losing a person because people can't be in more than one spot at a time. So if we do 4 times 3 times 2 times 1, that's how we get our 4 factorial up there.